Good day, guys. I hope you're all doing so well. So namhlanje we're coming with the fourth theorem, theorem number 4, and I hope you have enjoyed other videos or other the previous theorems we've just explored. And don't forget to subscribe and like for more content as you're preparing for a trial examination or preparatory examination in September. So you need to build quality as you're approaching your final examinations, guys. So let's just start. So you have a circle with 4 points on the circumference A, B, C, and D, and you have a center O. Now this is theorem number 4. It says that angles subtended by a chord. Remember, guys, what does it mean to subtend? To make. So if you have angles subtended by a chord or an egg, this is a chord AB or arc AD. This is an egg. It also acts as a chord. They're the same basically. Yes. We have angles subtended by a chord, meaning this chord AD, it makes angles. Which angles? We have this angle at this point and angle at this point, meaning angle subtended by a chord. Chord AD subtends these angles, this angle and this angle B and angle C at the circumference of a circle on the same side of the chord are equal. Meaning, I just want to demonstrate it on the diagram. How are they equal? Those two angles when they are subtended by the same chord. So you have chord AD that makes two angles. So at the circumference of a circle on the same side, meaning they are subtended by on the same side, which is side AD, it makes two angles, which is B and C. So if AD makes two angles and those angles are subtended by the one chord or on the same side, they are equal. Therefore, this angle is called this angle. How do you demonstrate it on the diagram? You can just use your hands. You can just use okay. AD subtends B, also AD subtends C. Therefore, B and C are equal. We call it butterflies. Therefore, angle B equals to angle C, or angles in the same segment are equal, meaning angles subtended by the same chord are equal. It's chord AD. Yeah, if they're subtended by chord AD, it means those angles are equal. You call it butterfly. You call them butterfly angles. So I'll just show at a later stage. Then how do we prove angle B is equals to angle C? I think this theorem is examinable. Yeah, I think you must just understand it. How do you deal with it? So now we are given that I'm proving angle. Indeed, these angles are equal. B and C that are subtended by the same chord. So you are given a center or circle with center O, such that AD or with AD subtending angle ABO, and angle ABD, not BO, guys. Angle ABD and angle ACD. Meaning you have AD, which makes or which subtends ABD, meaning with this angle, and also ACD, this angle. Yeah. Then we are required to prove that indeed ABD is equal to angle ACD, meaning you are quite to prove this angle is equals to this angle. Yes, guys. Then now construction. Remember, we have 4 heads we can use to prove we can use to prove certain angles are equal, especially in theorems. So we have the given, we have the required to prove, and we have construction and the proving. Then construction, how will you what do you construct here? We have center here, and you construct radii, meaning radii are lines or scattered lines or lengths or sides from the center to the circumference. It is a line that touches the center and a point on the circumference. These are radii, guys. So now we'll prove that this angle is equal to this angle. This is our construction. It is a mark. It is a mark in the examination. So radii OA and OD, which are radii, guys, and radii are equal. Remember that. Now let us prove. Okay, let's prove okay, indeed angle B is equal to angle C. Now, guys, let us check from the diagram. According to theorem number 2, if you have an angle at center, this angle is going to be equal to twice the angle at circumference, meaning this angle, it correlates with this one and this one, because we have an angle at center, and this angle at center, it is twice the angle at circumference. Even also similarly, this angle, it is twice this angle at circumference, meaning I will just name it, okay, I will just name it angle AOD. AOD is equals to twice ABD, twice ABD. AO, this angle, is twice ABD, this angle. Reason, angle at center, equal twice, 2 times angle at circumference. You can just write it in full. Angle at center equal 2 times angle at circumference. You can just write it in full, not the way I write it, guys. Yeah, and I'm just making sure everything is short and simple so that you can understand very well what I'm talking about. Another proving, it is of, again, AOD is equal to twice ACD. Simple, ne? AOD is equals to twice ACD. Reason, same reason. Angle at center equals to twice the angle at circumference. Now, guys, we have an angle, AOD, meaning we have an angle here. You can see this angle is equals to this angle, or it's called 2 times this angle, ABD. Also, again, the very same angle at center is equal to 2 times angle at circumference. It means each of these angles, each or both angle ABD and angle ACD, each or both equal to AOD. That means subsequently, this means these 2 angles are equal because of what? They're equal, meaning they're equal to the same angle at the center, which is the angle at center. So we have 2 times ABD that equals to 2 times ACD. Reason, each equal AOD. Then you are done, guys. Then now already you know 2 divided by 2 is 1, so we are left with ABD that equals to ACD. I hope you understand how do we prove this theorem. Reason for the use of this theorem, of to say that angle B is equal to angle C. The reason we use for this theorem, or to prove the angles, those angles that are certain by the same chord are equal, we say that the angles in the same segment, or can just say angles obtained by the same chord are equal. Then we are done. On the reason part, you just say angles that are subtended by the same chord, or angles subtended by the same chord. Angles subtended by the same chord. Then you are done, guys. Let us go to example that proves the theorem, or that talks about this theorem. Yes, this is the example, guys. It's so simple. It said that determine x and y given resistance, because O, they will say O is the center of the circle. Yeah, so you determine x and y. So now this one is so simple. How do you determine x? You can see that there is some sort of a butterfly angles here. You can see we have an arc DC, and this arc, it subtends B, it also subtends A. Arc DC subtends B, it also subtends A. Yeah, this angle here. That means by default x here is equals to x here by default, because of what? The two angles are subtended by the same arc DC. I hope guys you understand. Then now we have an angle here 132, and you have a straight line AD here. I can use angles on a straight line rule, or theorem, to find the value of x, because x and 132 on the straight line, angles on a straight line. So I'll just say x plus 132 is equals to 180. Reason, adjacent angles on straight line. Or I can just say angles on a straight line, then you're done. Then you find x, obviously. What is the value of x? You're gonna just transpose that 132 equals to 180 minus 132 equals to 48. By default, because we've proven these two angles are subtended by the same arc, that means the very same x that you got, for which is 48, is equal to the very same x here. So that means we're gonna have 48 here and 48 here. And they said you must find the value of x and nothing more. Yes. Then how do I find y? Here's my y, and y is angle at center, and this angle at center is equal to 2 times angle at circumference. Angle at center also, again, this angle is equal to 2 times this angle. So you can just choose which one do you use to find y. You can use both of the two angles, not a problem, as long as you understand. As long as you understand, guys. So now let us find y. Y is equals to 2 times, you can just use x, you can just use this angle or this angle, it's not a problem. Let me just use this one. Yes, 2 times 48, raising angle at center equals 2 times angle at circumference. Then 2 times 48 is 96. Then you are done with finding x and y. Let us go to theorem 4b, the converse of 4a. So guys, the converse of theorem 4a is that if a line segment joining two points subtends equal angles at 2 points on the same side of the line segment, then these 4 points are on the circumference of a circle. I'll just explain it right now. What does it mean? So we have a line segment, and this line segment, we are basically given that angle B is equal to angle C. This is what we are given basically. And if we have a line segment, AD, this is our line segment joining 2 points subtends equal angles. Meaning if line AD, it joins these 2 points, it basically subtends, or it makes those angles to be equal. Meaning this line segment, if it joins these 2 angles, because we have it joins the first angle, it also again joins the second angle. which is angle C. If the situation is like that, means these two angles are equal, then it's like that. Add 2 points on the same side of this line segment, then these 4 points are on the circumference of a circle. So if the situation is like that, it means this, if the two angles are equal, that means these 4 sides are on the circumference of the circle. Now they are called concentric. They are called concentric. That means we have, if the situation is like that, it means we have something like a circle. I'm not good at hand drawing, guys. Hand sketch, yeah, but I'll just demonstrate on you how the situation. If you have a circle like this one, or if these angles are equal and subtended by the same line, or are made by the same line segment, or they are joined by the same line segment that are equal, that means we have these 4 points on the circumference and are called concentric, basically. So if we have 4 points on the circumference, that shape is our quadrilateral. It's quadrilateral, and a quadrilateral that has 4 points on the circumference, it is called a cyclic quad. If 4 points touches the circumference, if the 4 points of the quadrilateral touches the circle at 4 points on the circumference, that means that kind of arrangement is a cyclic quad, or that kind of shape, or it forms that quadrilateral. It forms a cyclic quad because it touches the circumference on 4 points on the circle. Yes, so a cyclic quad is a quadrilateral where the corners on the circumference of the circle, the corner, it touches the circumference of the circle. That is the cyclic quadrilateral. I hope guys you understand that. So the reason for this use, when we are given that indeed the two angles are equal and are subtended by the same chord, we want to say line segment subtended equals angles on the same side. Line segment subtends equal angles on the same side. And this is one of the first reasons to prove that indeed this is a cyclic quad. This is one of the reasons you can use to prove that indeed this quadrilateral is a cyclic quadrilateral. I'll just show you in the next example how do you prove that indeed this quadrilateral is a cyclic quad. So the first reason to use is angles subtended by the same chord or arc. So if angles subtended by the same chord, that means that quadrilateral is a cyclic quad. This is one of the first 3 reasons to use when proving that indeed that quadrilateral is a cyclic quad. So I'll just show you in the next example, because how do you prove that a shape or a quadrilateral is a cyclic quad. I hope you understand in that order, guys. Here is an example. So this example is so simple. It says that prove that P, Q, and S is a cyclic quad. And remember, I said to you that if ever we are given a situation like this, that is what butterflies. Butterflies angles. This angle and this angle, this one and this one, they are butterfly angles because they are subtended by the same arc or chord. Meaning angle P is called angle S because these two angles are subtended by the same line segment, or are subtended by the same arc QR. Even this angle and this angle are equal because they are both subtended or are made by one arc, which is PS. So since you have angle P which is equal to 50, that means 50 is going to be also here, meaning you must prove that angle S equals to 50 basically. I'll just show you right now how do you prove it, guys. Yes. So to prove that angle S equals to 50, you need to need to know the value of R1 and M1. You can see that this angle 110 is here, and it is on a straight line with M1. So I can find M1 by the use of angles on a straight line. So M1 plus 110 is equal to 180. Reason angles on a straight line. Now guys, then how do you find M1 is equal to 180 minus 110 is 70. Then you're done with M1. Yes guys, then 70. Subsequently or similarly, I can find R1 by the use of the same reason, angles on a straight line, to find R1. So R1 plus 120 is equal to 180. Reason angles on straight line. Then R1 is equal to 180 minus 120 is 60 degrees. We have 60 here. Therefore, can use interior angle of triangles to find angle S. Then M1 plus R1 plus angle S is equal to 180. Reason interior angles of triangle are supplementary, or they add up to 180 degrees. Then M1 is equal to 70 plus 60 plus S equals to 180. Then 180 minus 70 minus 60. Basically 180 minus 130 is equal to 50. That means angle S is equal to, that means therefore angle P is equal to angle S. Reason angles in the same segment, or angles obtained by the same arc or chord. Therefore PQRS is a cyclic quad. Like before you can say that angles in the same segment, you can just say before this reason for now, you cannot use this reason for now, because you need to prove what indeed those angles are in the same segment. So just say each equal to 50 degrees. Then you're gonna use the very same reason when you say therefore, when you conclude the proving, prove that PQR is a cyclic quad. Therefore PQR is a cyclic quad. Reason angles in the same segment. So with geometry or cyclic geometry, cycle geometry, when proving theorem, especially when they say that prove this thing is a cyclic quad, before they can tell you what is a cyclic quad, you need to prove what it indeed is a cyclic quad. So you cannot just say when you're given a particular diagram like this one, or the previous diagram, and you just prove, then you just say, okay, these two angles are equal. They need to tell you what you must prove. They need to tell you what it is a cyclic quad. If they do not tell you it's a cyclic quad, or if you don't see anything that proves that indeed is a cyclic quad, then you are not allowed to use reasons of proving what is a quadrilateral is a cyclic quad. I'll just show you as we proceed later on with the the reasoning, or with this theorem of cyclic quad. No guys, so let us go to the corollaries. Corollaries, yeah, they call them corollaries of theorem number 4. So these ones are not partial, they are partially examinable. So I'm not sure about, but they're not asked more time, but you just need to understand them, go to what is what and which is what. Now we have corollaries. Corollary, we have in this case we have this theorem. It says that if you have equal chords, in this case we have chord BC is equals to chord FE. If you have this kind of situation or arrangement of a circle, This chord will subtend equal angles at the circumference, meaning if you have this chord, if the chords are equal, they will subtend equal angles at the circumference. Then we are done, guys. This means these angles are equal. If the two chords are equal, that means the very same angles on a circumference that they subtend, they are equal. Simple, ne? That means angle A is equal to angle D. If and only if the two chords are equal or arc equal. The reason for this theorem you can use is that equal chords subtend equal angles at the circumference. Then you are done, guys. Equal chords subtend equal angles at the circumference. I think this one, it appears once in a while, but I'm not sure about its examinability, but I'm not sure, guys. So just understand the difficulty. How does it roll? So let us go to the last example, perhaps. Yeah. Last example is so simple. So last example is so simple. I think this one is straightforward. Straightforward. It says that we have a quadrilateral. Because why do you say it's a quadrilateral? Because there are 4 points on the circumference. But you're not sure this is but you're not sure it is a cyclic quad because you're not told on the diagram. But you can use theorem 4 because we can see that there's a butterfly here. These two angles are subtended by the same chord. That means this angle is equal to this angle. That is the first thing we have noted on this diagram. So let us move. So they say that AB is equal to BC. AB, where is AB? AB, this side is equal to BC. This side, meaning this side is equal to this side. What does this mean? It means the adjacent angles are equal. Remember that angles are opposite equal sides. That means A2 is going to be equal to angle C. If angle C is equal to angle F, that means A2 is going to be equal to angle C and F. Simple, ne? I hope you understand, guys. Yeah. Now, let us move here. Calculate which represents the size of angle F. How will I find angle F? And they told you that ABC is 50 degrees. Angle ABC is 50 degrees. Meaning this angle, all of it. This angle is equal to 50 degrees. This angle B1 plus B2 equals 50 degrees. How will I find A2 and C, angle C? If we have sides that are equal and angles that are equal also. So first thing, number A, I'm going to say that A2 is equal to angle C, reasons angles opposite equal sides. So this means I can use in terms of triangle to find A2 and C. Since well they're equal, I can only use one angle to find both of the two angles, A2 and C. How? You're gonna just say angle B plus angle A2 plus angle C, they equal to 180 degrees. Using interior of triangle equal to 180 degrees. The angle B is equal to 50 plus A2 unknown plus angle C unknown equal to 180 degrees. Then A2 is plus angle C equals to 180 minus 50. So you can just go to you can just say 180. You can just transpose that 50 to the right hand side and you say 180 minus 50 is 130. Then the two angles are gonna share that 130. So A2, I want to say 130 divided by 2 is 65. Yeah. Therefore, A2 equal to 65 and angle C equal to 65, guys. 65. Now I can find F because we said that F previously I said that, or in the beginning you said that angle F is equal to angle C because we see a butterfly angles and they're also subtended by the same chord AB. Simple. So angle F is equal to angle C, reason angle subtended by the same chord or angles in the same segment. Therefore, angle F is equals to 65. We are done with number A. I hope you understand how did you find F. Then now, angle F is equals to 65. Then number B, they say we must find B. Number B, they say we must find angle D. Angle D. Where is angle D on the diagram? Here's angle D. Angle D is so simple. So you have a triangle here, A3 and B3. Angle D is here. How can you find angle D? And you can see that angle D, you can see a quadrilateral here, A, D, B, and C. How will you find angle D? You can also see that, but they didn't tell us this is a cyclic quad, so you will not say angle D is equal to angle C equals cyclic quad. No, we'll just move along until you figure that out at a later stage. So we have chord AB here, chord AB, and chord AB, it subtends angle D and angle F. If you can look at it correctly. So we have a chord AB, it subtends D and also it subtends F. That basically means we go to angle F equals to angle D. Angle F is equals to angle D. I hope you understand, guys. Angle F is equals to angle D. Reason angles subtended by the same chord or angles in the same segment. So angle F is equals to angle D. Reason angles subtended by the same chord or angles in the same segment, just the correct angles in the same segment. Therefore, angle D is equals to 65. Then you are preciously done, guys. Enjoy your day. I hope you'll find this video in order. Enjoy. Thank you very much.